Hi everybody, this is Mrs. Lehman from Math with Mrs. Lehman, and I just wanted to report in since you probably thought I was MIA because we spent the last 3 days working on our Module 1 test, so we're all done with that. So today we're starting Module 2, which is about arithmetic operations. So basically we're going to be looking at fractions and decimals and doing operations with those, so adding, subtracting, multiplying, and dividing, and that's the extent of Module 2. We are going to throw in some things like least common multiple, greatest common factor, and whatnot. But today we're going to start off our lesson with converting some fractions to decimals. So to warm you guys up, we're going to look at a skill we learned in Mod 1, which is to take a fraction and scale it up. So we have 2/5. If I wanted to make that out of tenths, what would I multiply by, everyone?
2.
Very good, times 2. Do the same thing to the top. 2 times 2 is 4. So who can tell me how I would write 4/10 as a decimal? Ryan?
0.4.
Very good. So that's what we're going to practice today, just converting these fractions into decimals. Now, the real trick is we're going to look for some fractions that have denominators that will easily scale up to a power of 10. So does anyone know what a power of 10 is? Liliana. Ooh, you guys are good. I didn't know you would know this. Well, hopefully you do. I haven't gotten the answer yet, so go ahead.
It's numbers that you can multiply by a whole number to get 100.
Oh, okay. So you're talking about those, like what we call the magical denominators.
Oh.
But a power of 10.
You have to multiply it by 10 as many times as, because there's going to be a 10 on the top, and then there's going to be a big number, which is the number how many times you multiply.
Good guess. Oh, you're talking about a base and exponents? Yeah, it's based on that concept where the base is always 10, right?
You have your numbers, and then there's a small number in the corner, and that's how many zeros the number has.
Very good. You guys did some scientific notation last year, right? I think that's where this is coming from. So, kids always forget what they learned the year before. They're like, well, I don't remember that. I had kids this year claim they didn't know how to do inequalities. Like, seriously? Check the tape. It's on there. But anyway, so a power of 10, essentially, like, if we have 10 to the first power, that's 10. Right? If we had 10 squared, that would be 10 times 10, or 100. And they call exponents powers sometimes. So if we have a 1 with zeros after it, it's a power of 10, okay? And that's what our decimal system is based on. So when we have like 0.125, for example, this place is what we call our tenths spot. This would be our hundredths spot, and this would be our thousandths spot. So if we can get our denominator out of a power of 10, so it's either 10, 100, 1,000, etc., a 1 with zeros after it, then we can easily convert that into a decimal. What a lot of kids mistakenly think is they think somehow, like for example 2/5, they think that it's really as simple as 0.25 or 2.5. That is not how that works at all. All right, you need to make it out of a power of 10, or you can take any fraction and divide your numerator by your denominator. So in this case, 2 divided by 5 is 4/10. But we're going to work on the skill of scaling it up to a power of 10 denominator and then converting it into the decimal world, okay? So anyway, to get from 51 to 100, we multiply by 2. 3 times 2 is 6. So 600ths. Who can tell me how I'd write 600ths? I haven't heard from Olivia yet. Go ahead.
0.6.
Ooh, that's a common mistake. 0.6 is what she said. Now, this first spot would be 10. So if we had 0.6, it would be 6/10. We want 600ths. So you want to fix your answer? Okay.
0.06.
Very good. Does Does everyone see the difference there? Be like saying a penny and a dime were worth the same amount, right? They're not. Just like 600ths and 6/10ths are totally different. Okay, so, oh, the red robin order was just read. Anyway, official business of school. Actually it is, but moving on. Do you have a question, Lorelai? I just called you Lorelai. I'm sorry. Lonnie?
How come the one is tenths and it isn't
That's place value. So you know, like the first spot right here would be ones place. This is tens, right? This is hundreds. Well, we don't have like a once spot. We have a tenths, hundreds, thousands.
I know.
I guess I don't understand your question.
No. Why isn't it like this? Like the last one's thousands. Why isn't number one the thousandth place and then the last one the 10th place?
Oh, because you're saying it kind of seems backwards compared to the ones. Yeah, you're right. It does seem backwards, doesn't it? Because as you go further right, they somehow magically get smaller, versus when you're going left, they get bigger. I don't really know what to tell you on that one. Well, you just kind of have to look at this and try to remember tenths, hundredths, thousandths, because you're cutting it into smaller and smaller pieces. You know what I'm saying? If you only have 6/100ths of something, you have 6 parts out of a total of 100. Where if it was 6 out of 10, that's a much bigger amount. It's closer to being one whole, right? So these are whole numbers to the left of the decimal. These are partial numbers. You know, it's representing a partial amount to the right. Does that make sense? Okay. Man, you guys are getting into some really deep questions here that I'm not 100% prepared to answer. We're going to go to the next page, which is a beautiful cover. Whoa, all right, and then go to the next page, which is the start of lesson 9. New York State had a really interesting way of putting these lessons in order, and the 6th grade teachers that work here decided that our way was better. So we did some rearranging of the lessons. So just ignore the fact that we're starting with 9. We may have skipped 1 through 8, whatever, it's okay. We only have 180 days in a school year. It's kind of necessary to adjust some things. So anyway, we're going to start by taking these fractions and turning them into decimals. We're going to convert them. So we have 25 and 3/10. So how would I write that? 25, and then when you say and, that's where the decimal point goes. Everyone stopped watching this video by now, I'm 100% sure of. So 25 and Tucker? 0.3, very good. So that's where the tenths place is. Plus 376. Now 77/100ths, how would I write that? Point what? Lorelai?
0.77.
Very good, 0.77. Now, let's go back to the top of this page where it says sums and differences of decimals. What does the word sum mean? The answer when we do what operation, Rihanna?
Addition.
Very good. So this means addition. Differences means we are doing what, Tucker? Very good. And decimals. Who knows the trick of adding and subtracting decimals? What do we need to do? Lonnie?
We don't use the decimal until the end.
Nope. You're thinking of multiplication. Some stuff there.
But the decimals need to line up.
Very good. We need to line up decimal points. Now, hold on, let me write this. Line up decimal points. When you're adding numbers before you even learned about decimals existing, you learned to line them up, to stack them, right? Because you wanted your ones over your ones, you wanted your tens over your tens, hundreds over hundreds. Same concept, we just got to make sure they line up. That's why we've got to have that decimal point that you don't see typically if you just have a whole number. No one's writing the decimal point after it unless there's some remaining part, right? So you got to just line up the decimal points when you add and subtract. So first step here, we're just going to stack these numbers. And we're adding, so we're finding the sum. Now right here after the 3, we have 3/10, right? Do we want to do this? Yes. Am I changing the value of that at all? No. So that is totally math legal. We're going to go ahead and add 0 plus 7 is 7, 3 plus 7 is 10. Carry the 1. Before I go any further though, I've got a decimal point that I need to bring straight down. 1 plus 5 is 6. 6 plus 6 is 12. Carry your 1. 1 plus 2 is 3. 3 plus 7 is 10. Carry your 1. 1 plus 3 is 4. So your answer should be 402 and 7/100. Did you have something to say, Olivia? Perfect. All right, we're going to practice some more. Example 2. They're going to give you one that does not have it already with a power of 10 denominator. We have 426 and 1/5. Question or comment?
A question on the top. Isn't it different because this is 10 and this is 100?
Well, that's why we put the numbers where we did. Ooh, wow. Sorry. So because this is 3/10, that's in the 10th spot right there. This is 77/100. Remember, you read decimals with the last spot it's in. Okay. Let's go down here to this next one. So we have 1/5 and 1/2 that we need to convert. So 1/5, we want to make that out of a power of 10. So to get from 5 to 10, what are we multiplying by?
5, 2.
Ooh, people are getting upset when people make a mistake. All right, 5 times 2 is 10. You must be angry all the time in here with me teaching you math. I mean, I goof up like it's my job. All right, so 1 times 2 is 2. So this first number here, we're going to have 426 as our whole number and 2/10. So that's going to be 0.2. All right, the next number we have 1/2. So I'm going to do this one down here, 1/2. Can I scale that up to a power of 10? What power of 10? Tucker? We could go all the way up to 100, but I don't need to. Usually it's best to go with the lowest one. No, that's not a power of 10. So I'm looking for a number 1 and zeros. Kaden? 10, yep. So we're going to multiply by what to give us 10? What? 5, yep. Everyone's afraid to answer because their classmates are going to go, it's not right. All right, 1 times 5 is 5. All right, so 5/10 as a decimal, that would be 0.5, right? But we have a whole number in front of it, so 275.5. Now we need to stack these to find the difference. 426.2 minus 275.5. All right, so we're going to go ahead and subtract here. So 2 minus 5 can't happen. So we got to borrow from the 6. That's going to become 5. 12 minus 5 is 7. 5 minus 5 is 0. Bring down that decimal point. All right. 2 minus 7 isn't going to work. Okay. So I was just having a moment like, did I write those numbers down correctly? Okay. So 2 minus 7 doesn't work. I've got to go next door to the 4. Borrow. 12 minus 7 is 3 minus 2 is 1. So your answer for the first example is 150, actually example 2, sorry, 150 and 7/10. All right, now we're going to deal with some word problems. So you have a few steps here. First thing we're going to do is read the question, underline key words. We're going to decide, are we adding or are we subtracting? We've got to then take those numbers, we're going to convert them into decimals, and then do the operation. Okay, so that's the plan, Stan. All right, Samantha and her friends are going on a road trip that is 245 and 7/50 miles long. They have already driven 128 and 53/100. How much further do they have to drive? What am I going to underline here? Liliana.
245
Very good. And then 128 and 53 hundredths will be the other part, right? So we know there's a total distance that needs to be traveled. We know we traveled that amount. And the question we have to underline is how much further do they have to drive? We have to make a decision. What operation are we going to use here, Peyton? Subtraction. Very good. Why? Yeah, and what key word told you we're going to subtract, though?
How much farther they have to drive?
Very good, Olivia. Yeah, so nice job, you two. So we need to convert this 7/50ths. All right, so 7/50ths as a decimal. Now we're looking for a power of 10 down here. What power of 10 do I want? 100. All right, Paula, to get from 51 to 100, we multiply by? Very good. 7 times 2 is 14. So we're going to write that as 0.14. All right, so this 245 and 7/50ths is the same as saying 245 and 14 hundredths. It's the same value. All right, 128 and 53 hundredths, how would I convert that? Point what? 0.53, because that's already in the in a fraction that has a power of 10. So we need to subtract, you guys said, so 245.14 minus 128.53. All right, so let's go ahead and do that. 4 minus 3 is 1. 1 minus 5, can't do it, got to borrow from this guy. 11 minus 5 is 6. Bring down your decimal point. 4 minus 8 can't happen, you got to borrow. That'll become 14. 14 minus 8 is 6. 3 minus 2 is 1. 2 minus 1 is 1. So what label would I put on this answer? What are we talking about, Tucker? Miles, very good. So, woo, 116 and 61 hundredths miles left to go. Let's go to the next page. All right, we've got Ben. Ben needs to replace 2 sides of his fence. One side is 367 and 900ths meters long, and the other is 329 and 3/10ths meters long. How much fence does Ben need to buy? So, key things. We've got this piece of fence, this piece of fence. We want to figure out total how much he needs to buy. What operation, Tara, do you think we're going to do? Very good. Addition. Great timing, right, Olivia? Don't worry, no one's watching anymore. I'm just kidding. All right, so 367. Now this one's pretty easy. It's 900, so we're going to put 0.09. Okay? 329 and 3/10. So we want that 3 to be in the 10th spot. It would go right there. And Tara told us we are adding. That's Olivia. All right, so 367 and 900ths plus 329 and 3/10. Again, we can add a 0 here at the end because after the last digit, it's okay to add as many zeros as you need. 9 plus 0 is 9. 3 plus 0 is 3. Put your decimal point down. 7 plus 9 is 16. Carry your 1. 7, or 1 plus 6 is 7. 7 plus 2 is 9. 3 plus 3 is 6. So we have 696 and 39 hundredths what, Evan? What are we talking about?
Fences.
But what are we measuring the distance of the fence in? Wait, very good. So we want meters as our unit. All right, so we have one more to go over in class, and then I want to show you what I expect on your homework, okay? So we have to kind of fly through this one. Mike wants to paint his new office 2 different colors. He needs 4 4/5 gallons of red paint, 3 1/10 gallons of brown paint. How much paint does he need in total? So 3 1/10 is really easy. That's 3.1. 4/5, well, there's no 5th spot. All right, so we've got to scale it up to the 10th spot. 5 times 2 will give me 10. 4 times 2 will give me 8. So this would be 4.8 gallons. Are we adding or subtracting these? I'm hearing both answers. Brianna, what do you think? Very good, you're correct. 4.8 plus 3.1, because we're looking to combine these two to make, oh no, he's not combining them. A lot of times they'll give you examples of them combining paint. What? Did I do something wrong? What are you confused on? Why we're adding? Yeah, you're supposed to add. Did I say subtract? I did?
No.
I don't know.
You didn't say
The record, it will be on record. I don't know. I misspeak a lot. I'm trying. When I hurry, I start making mistakes. So I'm not sure what I did. If I said it or not, I'm going to check later. But anyway, 8 plus 1 is 9. We're adding, remember. And then 4 plus 3 is 7. So this would be gallons. Now, before you go anywhere, I know you're itching to get out of here. If the bell rings, hold on a second. You don't have to walk any further than one classroom away. All right, on your homework tonight, you 5, A, B, C, D, those are all, and E are all really easy. You're just going to convert those into decimals, add or subtract. Now, question 6 is where kids are going to go, I don't know how to do this. And that's probably why they're watching right now. All right, so you have 422 and 3/7. Now, 3/7 is not, if you go like this, you're never going to get that to go out of 100, right? That's not going to work. So what you need to do is take 3 and divide it by 7 to find that decimal point. All right, so you're going to have 422 as your whole number, then 3 divided by 7. That's going to give you that big long number, okay? Now it tells you to round your answer to the nearest hundredth, right? So we don't want to keep rounding because our answers will become really inexact if we keep rounding too much. So to keep some precision here, what we want to do is we're going to go to the thousandths place. So you can cut it off after the 8, do all the calculations with this number and the 367 and 5/9, do the same thing, go to thousandths. Then, once you get your answer for that, go ahead and round to hundredths, okay? We just don't want to get rounding happy, because if you keep rounding, your numbers become less and less exact, okay? Any questions on what you need to do for your homework? That one says, wait 1 second, you are allowed to use a calculator. Thank you for watching. Hopefully that helped with your homework tonight. Don't forget to like and subscribe.